So today I've got access to another restricted area. I'm going to learn all about MRI machines that can scan your whole body and even into your brain. Let's go find out. So we're back here again with our resident medical physicist, Niamh.
Thanks for having me back, Dan.
No problem at all, Niamh. Delighted to be here. So, the last time with Niamh, we learned all about CT, computer tomography, and PET scan, positron emission tomography, right?
Yes, exactly.
And today we're here to learn about something completely different, MRI. So, Niamh, can you tell me what is MRI?
So MRI stands for magnetic resonance imaging. And what's really nice and cool about MRI is that we actually use a magnet to see inside our body.
Okay, so this giant machine here is an MRI machine.
Yeah, there's a big, massive magnet in there.
Okay, and I've heard it's like the most strongest magnet in all of Ireland.
Strongest magnet in all of Ireland.
Okay, and the reason I know is you might have noticed I'm not wearing my glasses today. I had to take them off because there's metal in them, and you can't go anywhere near an MRI machine with any metal because it will fly off and get stuck to it and ruin the whole machine, and we're not supposed to do that. So and it could bang off someone. Just no metal near the MRI machine.
Yes, exactly.
So what I want to learn today, Niamh, is I want to learn what do we use MRI machines for and how they actually work, because I know it's super complicated.
Yeah, so MRI machines are really good at looking at the soft tissue in our body. So X-rays and CTs are really good at looking at our bones.
Yes.
But if we want to look at our tendons, our ligaments, our blood vessels, MRI is where that comes in.
Our brain too?
Our brain too, exactly.
Okay, lovely stuff. So right, we lie on this table, something like that.
Exactly.
We slide into here.
Yes.
The magnet does this thing and we can see our brain and our organs and all that stuff.
Yeah, so our body's made up of about 70% water.
Uh-huh.
So water is H2O.
Yes.
So that's 2 hydrogens, 1 oxygen.
Yes, I know that.
So when we go into the magnetic field, all our hydrogen atoms start to spin and they all line up really, really nice and straight.
Okay, wait, so when we go into this magnet, it like tweaks all our hydrogen atoms in our whole body.
In your whole body.
Okay, and they all point in a straight line. Okay, cool. So our hydrogen atoms are pointing in a straight line. How is this going to get an image of what's going on inside our body?
So then what we have is what we call an RF coil. So this releases radio frequency, which causes these molecules to spin out of alignment.
Okay, whoa. So our RF, so some radio coil.
Yeah.
And that sends some sort of mad radio signal and it causes the atoms in our body to tweak their little spins.
Exactly.
Okay, and hold on. Is this an RF coil here?
That is, Dan, yeah.
Okay, right. So they like click on over your head or your chest or your leg or wherever it is they want to look at.
Yes.
Okay, and is this like what we had in the last place? We had a phantom, right?
It is, yes.
Okay, so phantoms are like things that you can image easily to make sure everything's working well.
Yeah, to make sure that our scanner is working as best it can. Scan these phantoms and then we can tick to say that it's working properly.
Okay, perfect. Okay, so hold on, let me follow this. We go into the magnet, the giant magnet makes all of our atoms point all in the same direction, well, our hydrogen atoms,
yeah.
And then the radio frequency coil sends some radio signal which causes them to schwank over a little bit.
Exactly.
And then what happens next?
So then when the RF is stopped, when the radio frequency is stopped, all those hydrogen atoms go back into alignment with the magnetic field.
Yes.
And as they do that, they release energy.
Okay, right.
And that energy is used to create the image.
Okay, right. Okay, so hold on. In our CT scan, we blasted some radiation, some X-rays, and that was the image.
Yeah.
But here, we put you in a giant magnet, we put radio frequencies which flip the little spins of our little hydrogen atoms. They flip back, and they send off a radio frequency. That's picked up by the sensor, and that gets us an image.
Yeah.
Okay, that sounds super complicated. But you know what? Will we go and have a look at some images and see what we can see?
Yeah, perfect.
Okay, so before we go and look at those images, Niamh just wanted to talk a little bit about safety, because safety is super important about MRI, right?
It's very, very important. So because we can't turn off the magnet, it's always magnetic. So we have to make sure that we have no metal on us before we go into the room. Otherwise, it will be attracted to the magnet.
Okay, right. So we have to empty our pockets.
Empty your pockets.
Take off the glasses.
Take off your glasses.
Yeah.
If you have a pacemaker for some older patients, we have to make sure it's what we call MRI compatible. So to make sure it's safe to go into an MRI with.
Yes, and you don't want some metal part of your body getting flying out or something like that.
Exactly.
Some titanium plates or something. Okay, cool. And so we know it's super strong, this magnet, but is this what this 3T means?
Yeah, so 3T is the strength of our magnet. So T stands for Tesla, and that's how we measure the magnetism.
Okay, so this is a 3 Tesla magnet. So what, I don't know, a fridge magnet is what, maybe 1 Tesla or something?
More like a million fridge magnets.
Okay, right. Okay. So 3 is actually a huge number, I guess, in this
Really,
case.
really big
Yeah,
number, yeah.
perfect. Okay, cool. Well, I think we got the safety thing down. Let's go and look at some images.
Brilliant.
So I got my glasses back. We're a little bit further away from the magnet, so it's safe. But Niamh just told me one more fact about this magnet, this super strong magnet. It's actually a superconducting liquid helium cooled magnet. So what does that mean, Niamh?
So the magnet is really big and it works really, really
Yes.
hard. So there's loads of current going through it.
Electrical current.
Yes, electrical current. And because it's working so hard, it gets really, really warm. So we have to keep it really cold. So that's what we have, the liquid helium around the magnet to keep it nice and
Okay,
cold.
and how cold is that? Like as cold as a winter's day?
Oh, even colder.
Okay.
So if you think of minus 200 degrees,
Minus 200 degrees, even
Yeah.
colder than that.
Yeah.
And like the coldest temperature on Ireland would be what? Maybe -8 in a really bad winter.
on a
And
really bad winter.
in like Antarctica, maybe -30.
Yeah.
But this is over minus 270 degrees Celsius.
So it's very, very
Okay,
cold.
that's super cold. But anyway, we got their cold magnet under control, but what's going on with these images? Can you explain what we're seeing here?
Of course I can. So, as I said, MRI is really good for looking at the soft tissue in our body. So our brain is mostly made up of soft tissue.
Yes.
So we can see from the image, we can see the brain, we can see the tongue, we can see the spinal cord.
Yes.
And we can even scroll through the images.
Okay, wow, we can almost, oh wow, it's like we're slicing through someone's brain and looking in there.
Exactly, yeah.
And you can look at all the different cool parts of the. Oh wow! It's like almost you got it and you went chop, but you actually don't have to chop the person's brain open.
Exactly, yeah.
Lovely. That's super useful. Cool. And so right, why do you take these images? What are you learning about them?
We can learn so many different things from these images.
Okay.
We can look at patients who might have Alzheimer's and things like
Okay.
that. But what's really cool is we can do what's called functional MRI.
Functional MRI. Okay, what is that?
So that's basically when we put somebody into the scanner
Yes.
and we look at all their brain activity. So we can put a TV in front of somebody,
Yeah.
they can watch the TV, and we
Yeah.
can see with our MRI images the different parts of the brain that are activated.
This is like, it's almost like reading your mind.
Almost like reading your mind.
If you're like sad or you're happy or you're angry or you're like moving your toes, your fingers, different parts of the brain will light up.
Will light up, exactly.
Okay, and they can use this information to learn loads and loads about different diseases, about how to cure people, about people who might have different issues, and even in their mind.
Yeah, exactly. So that's really, really why MRI is so good at all this brain imaging, because we can get
Okay.
so much information out of the brain.
Cool. Well, that is super interesting. So, our CT scanner was basically a big giant X-ray machine that can look
Exactly.
at your bones. That's kind of its job. But the MRI machine can look at all your muscles, all your organs, and it can even read your thoughts.
Exactly.
Okay, well, that is super cool. Niamh, thank you so much for teaching us about this. It's really good to have our medical physicists here that we can always talk to. And I'm looking forward to seeing you on another one. We can talk about something else.
Brilliant.
Bye, guys.